Great. Well, I'll stay on video just for a few seconds here, folks, as long as we're getting started, just so that you can see I do have a normal face and not an extra head growing out of me. So good morning, or actually good evening, depending on where you are. I'm really excited. This is the first time I presented for the Estonian Oracle Users Group. So another country to my list of countries that I've presented for. Today, I'm going to be talking about something very interesting, a set of features in Oracle database that actually are kind of overlooked in my opinion. And that's actually something called fast ingest and fast lookup. So first off, thanks for having me. Always love presenting virtually in person. In fact, I was just presenting in person for the first time in 20 months. About a week and a half ago in Dallas, Texas. And it was so nice to be with real life people again, so that you could actually get their responses and not try to guess how upset you are with me in the chat. But anyway, I'm going to cut my video for just right now so that we make sure we keep bandwidth, because that's important. You know what I look like for now. Here's a little bit more about me. I'm an Oracle ACE director. I've been around the block a few times with Oracle databases, but these days, even though I've co-authored 4 books, I spend a lot of my time in Illinois, which is a central state, sometimes as I am today. I'm actually in Wisconsin. I have as you might say in Russia, I have a dacha. I've got a summer house, right? But it was a beautiful spring day, or early autumn day, which means it was freezing last night here in Wisconsin. But I also spend my time now trying not to kill myself when I do amateur sports. These are real photos, by the way. I am the oldest guy in martial arts class. However, my wife is the oldest person in martial arts class. We pair up usually when we're doing martial arts together. You could reach out to me at Jim the Y Guy. That's kind of my handle these days. Follow me on Twitter. Check in with me on LinkedIn. I usually have some pretty interesting perspectives. So now that you know what I'm doing here, one other thing is that I have a podcast. I should say I'm a co-podcaster with my good friend and colleague, Lidon Amitsi. Lidon lives in Vancouver. I'm outside of Chicago most days. He's originally from Israel. I'm born and bred Midwest United States. We talk about everything except tech. And we've had some unbelievably great guests. We have some great episodes coming up. The basic idea is 2/3 of everything we're doing in technology has nothing to do with technology. We talk about the soft skills, everything from interviewing to writing a resume, all the way through how is it to manage technical people from inside and outside. So check out our podcast. We just dropped a new episode, I think Wednesday. It's a lot of fun. We don't do this for the money. We're not monetized. We don't have a sponsor. When it stops being fun, we're going to quit. And so far, it's been fun. But anyway, that's just a little pitch for that to brighten your day. Most of our podcasts are well under an hour. What are we here to talk about today, though? Well, here's the deal. In the real world, edge computing is where it's at. What you might want to call the Internet of Things. And there's a lot of different versions of this, right? I'll touch on just a few. The industrial Internet of Things, right? Everywhere you look in manufacturing today, everything's being measured, usually by tiny devices embedded in either the assembly process, the machines themselves. And I started out my first real serious job after quitting college, that's another story, was as a machinist. And it kills me here in the United States when people go, I want to go back and become a machinist and work in a factory. I'm like, those jobs sucked. They were terrible. I cut myself in 9 months working in a factory. I think I aged 2 years. This is not our grandfather's factories, right? These are extremely automated processes, and efficiency and time to market is everything. Another example, smart cities, right? I took this picture actually when I was in San Antonio, Texas, about 2 years back at, I think it was Collaborate 2019. Everywhere you go in most major cities today, there are electric bicycles or electric scooters. There is new activity here, especially in the USA, to even revise the way we handle stoplights, right? The estimates are somewhere in the billions of dollars, tens of billions of dollars of cars waiting at stoplights for no good reason, because there's not enough traffic to make them stop, right? We have autonomous delivery vehicles here in the USA. I'm sure in Europe as well, you have some of those things. I don't know why somebody wouldn't just knock over the robot and steal the food, but that's another story. Maybe that'll be part of the edge computing opportunity. Several other things that are really changing because of climate change. Here in Wisconsin, we are in a very rural area. Believe you me, farmers here are extremely motivated to make sure that their farming is extremely efficient, okay? They are constantly looking at over or under watering, efficient use of everything from fertilizers to weed applicants, pre and post-emergence herbicides, for example, and pesticides. Another thing that's really changing is food waste. Two aspects of that. Number one, here in the United States, 15% of all food goes wasted, either because it's not pretty enough or it simply gets thrown away. And that's outrageous. Restaurants are even installing cameras in recycling areas to make sure that people are effectively reusing food scraps. This is something that's going to accelerate as climate change comes to the fore, finally, thank goodness. This young lady here at the bottom right hand is a farmer in India. As you know, India is still a hugely agricultural country. It's getting too hot for humans to actually farm. When the temperature reaches 50 centigrade and the humidity is 100%, people will die, right? So again, IoT, being able to measure weather and humidity is something that's ubiquitous. Now, what's going to change? Everything. Everything's going to change. What's really going to happen here, especially in the United States, I don't need to tell you if you're in Europe, it's quite obvious already. Renewable energy is at the fore. We have a few people we're still trying to convince here, but one thing I'll tell you about renewable energy is very interesting. There is a museum of coal mining in Kentucky, one of our southern central states. That museum 4 years ago switched over to solar panels for powering the museum. If that isn't ironic, I don't know what is, right? There's all kinds of things that are happening. This is actually up in the right-hand corner here. This is a nuclear reactor that burns not uranium or plutonium, but spent nuclear fuel. This is actually, if I remember correctly, in Japan, right? Think of what's happened in the past 2 years. We are shifting towards working from home as becoming a new normal for many people. Well, that also means that office buildings are going to need a lot less power, but homes are going to need more power for computing and for just living at home. Green hydrogen is a raging debate here in the United States about taking electrolysis using renewables, right, to essentially crack whatever gases we have, even just cracking water into hydrogen and oxygen, and using that green hydrogen, a very effective way, depending on who you talk to, of storing energy, right? Because battery technology hasn't caught up yet to renewable energy. And finally, smart meters, which is going to be the focus of what I'm going to talk about today. I have a smart meter. Our electrical utility said we will give you a discount of up to 10% if our smart meter detects that there's a lot of electrical energy being used in your area. If you will simply not run your air conditioning or your dishwasher or your clothes washer at these times of the day, we'll give you a 10% discount. And it actually adds up to quite a significant amount of money. So this is where we're headed. And in the United States, people argue with me. I don't think I have to argue that heavily in Europe, especially, and even in Asia, because people realize this is where we're headed. We're going to electrify everything. And so using that as an example, How am I going to gather all this data? Because if you think about things like smart meters or a couple of other things, social media feeds, right? It's funny when I watch British detective series, especially from the BBC or from the UK, right? They always talk about, well, do we have a CCTV image of the perpetrator, right? That's not quite as widespread here as it here in the US. It's not quite as widespread in the UK, but images coming in from cameras is a perfect example of things coming in from the Internet of Things. Social media feeds, another example. I'm going to focus today on smart meters because if you imagine, right, if we have 180 or 200,000 households in a moderately sized city in the US here, right? In fact, there's a local city here named Naperville, Illinois, that runs their own public utility, and they have approximately 200,000 smart meters, and they have to gather that data sometimes as quick as every 15 seconds. How am I going to get that to load into a database and make it usable quickly and not overwhelm my database? Well, the answer is something called fast ingest. Now, this is a very interesting process and it's got pluses and minuses. But if you haven't seen it, stay with me here because we'll talk about this. Imagine I have high frequency inserts from any of these sources. How do I get them loaded quickly? Oracle's technology called fast ingest. By the way, this is available in 18C, but it's also available in 19C and beyond because I demoed it as the examples I'll share with you are in 19C and 21C. We're going to take the inserts and instead of using commits, we're going to take the rows from the inserts and batch them up in a special area of the large pool. More on that in a second. What happens is the database then directly writes the data to the data files without using a commit process. There are a series of drainer processes that write them into permanent storage. But wait, don't panic, because if you're a hardcore DBA, you're going, wait a minute, no commit? That means no rollback. Yeah, and there's a few other things here too. The idea here is I need to get these data loaded quickly, and I'm willing to trade possible dirty writing, if you will, and the inability to commit or roll back to make sure that I get the data loaded quickly. Here's how it looks in the scenario I'm going to share with you. So I built a little application using Swing Bench to simulate an application server generating transactions with about 15 user sessions to add single row inserts into an autonomous transaction processing. Well, I was trying for an autonomous transaction processing database, a little more on that in a minute, but into a 19C or 21C database using what's called the memory optimized row store, or MORS. And it's configured by the mem optimized pool size parameter. We're storing these rows in batches together in the large pool in that mem optimized row store area. The worker processes, that's not woo, that's W000 through N, and I'll show you more of that in a second, write directly into the data table spaces area for the T meter readings table. And then I'll show you some methods that we can use to verify that all the writes have actually happened. But that's our scenario for fast ingest. We'll talk about fast lookup in about another 20 minutes, in case you're waiting for that one. Here's my example, very simple schema right now. I have smart meters as a table. That smart meters table is essentially identified by an SM ID for the smart meter. So a business, a home, more likely a business may have more than one smart meter. Obviously, meter readings are the children of smart meters. I also have another little table here called business descriptions. I'll show you how I use that to do some analytics and machine learning against that to see some interesting things. I used two different test environments, a virtual appliance image of 19C. I believe it was 19.3 that I used. Of course, we're on 19.10 or 19.11 now, but that was on my own hardware. I also had a DBCS instance, a 21.1 instance with quite a bit more memory and 2 CPUs. And I'll share with you, of course, the AWR reports from actually using fast ingest in just a second, but I digress. Let's talk about what it takes to set up a fast ingest workload. Okay, so number one, I have to set mem optimize pool size to initialize that MORS or MORS, mem optimized row store area. And that means I have to bounce the instance. I'll never have to bounce it again. Okay, once I bounce it, this is just the way some things work in Oracle, right? So I set that, I bounce the instance, and the mem optimized row store is initialized. Okay, I'm ready to go. I change into my container because this is an autonomous transaction processing instance. I'm almost ready to go. And what? Wait a minute. The way I set up the T meter readings table in the sim IoT schema for writing to it with fast ingest is with the mem optimize for write alter table command. And it says, dude, can't do it. It's in an encrypted table space. I'm like, what are you talking about? Why wouldn't this work for an autonomous transaction processing database? I've talked to Andy Ribinez. I've said, Andy, he's the guy that handles all the in-memory stuff, right? This is kind of an in-memory feature if you think about it, right? By the way, there's a list of what infrastructure is actually supported. Right now, an autonomous database will not work with this because it has encrypted table spaces by default. Oh, so I've talked with Andy. I said, are you guys going to fix that? And he's like, number one on the list. So again, I haven't checked lately. This may already have been absolved, if you will. And in a way, it kind of makes sense. And I'll explain why in just a second. So what I did is I set up my two instances, my 19.3 instance on my own local hardware, and then a 21C instance on DBCS in OCI. Here's another thing. This runs on exadata. So to fake out exadata, this feature, I have to set underscore exadata feature on. Don't ever do this in production. This is merely to show some, not all features of exadata. If you do this in production and you get in trouble for this or something that you wanted to work on exadata doesn't work, do not call me, okay? This is merely for simulation purposes. So again, that's why I did it. And then, wait a minute, I'm a good DBA. I had the smart meters table and the T meter readings table linked with a foreign key. What do you mean I can't have a foreign key or straight? Well, here's the idea. Think about when we're working on fast ingest. It's like, as the saying here in the United States goes, drinking from a fire hose. Imagine you've got a fire hose. If you've ever had a fire hose and you know how much pressure is in a fire hose, you know what firemen use to put out fires, right? It's like your face would be melted by the pressure, right? The idea here is I want to load data as quickly as possible. Can I use Ranger hash partitioning? Yeah, that's allowed. And actually my example shows this. However, there's a whole bunch of other things that I can't do. Even foreign key constraints are not allowed. And I already mentioned the restriction on encrypted table spaces. Check out this particular Moz note for the limitations, a complete list of it. Most of these, however, do make sense. We are trying to load into a single table as quickly as possible, a boatload of rows, a huge number of rows. So we're going to have to make some concessions to do this. Again, we're not enabling the entire database to do this. We're talking about here, one table to do it, right? A couple of other things to think about. Transactions processing. I'm just going to wet my whistle here with a cup of coffee. Nothing like coffee on a cold winter morning, except it's not winter. Anyway, a couple of things to think about. All right, ingested data loading is extremely fast, and I'll show you. It's almost 40% faster, all things being equal. However, because we're writing in batches, if the instance should crash, it's possible to lose data. Don't worry, we have ways to verify if transactions were completed, all right? Commits don't make any difference. Commits also, if there's no commits, right, that also means no rollbacks. So you have to think about, right, if I've got a parent table that is committing, right, if I'm inserting into smart meters, T smart meters, what about T meter readings? Well, they may not actually be in sync if there's a failure, right, of the database. That's something else to think about. Also, until the data has been queried, sorry, the data can't be queried. There we go. Until it's been flushed to disk. Also, index operations, constraint checking, that only happens when the data is finally written from the fast ingest area, from that Moore's area to disk. Primary key violations, which really shouldn't happen in any well-designed schema, are not resulting in an exception. And finally, I have to make sure that my application, should I shut the application down, before I actually shut down the application instance or even a database instance, I need to make sure that all data that had been staged for writing was written. Don't worry, there's a way to check for that. So let's take a look at an example. Oh, before we do that, let's talk about $mem optimized write area. And the way this works is, by the way, mem optimized write area essentially describes what's going on inside the Moore's area. And so this little query here, and by the way, I think I've already sent in my slides, but I'll make sure we get the slides to you, right? I can see that, okay, here's that 2 GB of memory that we allocated. Very little of it has been used, but as I start a workload, you notice that the number of writes goes up, the number of writers goes up. I understand in later releases that, if I remember in 19.3, that number kept going up even though we weren't writing anymore, right? So I would expect that number of writers to have gone down. I believe in later releases that now actually does show accurately the number of writers right now, but in earlier releases, it was cumulative since the instance started. Num writes, though, went up and down, as I remember. And of course, free space goes up and down. So this is the easy way to see what's going on inside the Moors. Are things being processed? Is there activity, right? But that's kind of a raw way of finding out how things are being processed. What I also can do is check on, whoops, I think I lost the slide there. There we go, there we go. There is a way to validate the status of transactions. So here's the way this works. There's 2 procedure calls that you can make, really function calls. One called dbms mem optimize get apply high watermark. And by the way, that's the one that's misnamed because it's really a low watermark. And then a write high watermark. The way this works is the low watermark is for all transactions that have been written globally across the database instance. There's a high watermark that's specific to this section. So to kind of show how that works, let's say that I haven't started a workload yet in this particular session. There is a number, looks a lot like an SCN, but it's not. It's a low watermark. Don't mistake it for an SCN. Right now, the high watermark for this session is 0. We've done nothing. Now, as I start transactions, guess what? That high watermark for this session begins to increase. And you'll notice in this case, I know for right now, there's a workload that's been generated, but not all the rows have been written out for this session. How do I know that? Because the high watermark is higher than the global low watermark. Now, I stop the workload or it stops on its own accord. Now, the low watermark has surpassed the high watermark for this session. This session now has written everything out. Everything has been written out. So I know that at this session, if I had to cancel this session, or if the user, if you will, terminates the session, however this works inside our application, right? Everything's cool. Everything's been written. So that's good. I can see that. Now, can I also control this manually? And the answer is absolutely. I certainly can. 2 procedures. One's called dbms mem optimize.write end. Notice it's singular. That says for this particular session, please, if anything has not yet been written, write it now. Moore's, call your writers and write it now. I also have the ability with dbms mem optimize admin.writes, no plural, flush. This says, okay, I don't care what session is active right now. I want to flush all this stuff from the Moore's out to the data files of the table spaces of the tables that are activated for fast ingest. So I have a way to do it globally as well. Why would I do that? Because maybe I need to shut the instance down, right? Maybe I need to bounce the instance for something else. Maybe I need to do some major maintenance, whatever it might be. Just be aware I can control it at session as well as the global level. Now, what difference does it all make? Well, by the way, one thing I should have mentioned, not only do you have to enable the table for mem-optimized writing, you also have to use the plus mem-optimized write hint. So if you see that first SQL ID there that ends in G38, that's an example of using fast ingest, right? So by the way, you could have a table enabled for fast ingest and not use fast ingest, because without that hint, you can use commits if you wanted to, okay? But to get fast ingest working, you got to use the plus mem-optimized write hint. Hey, what happens if you use the the mem-optimized underscore write hint on a table that's not enabled? Nothing. What does Oracle do with a hint that's meaningless? It ignores it. It's a comment. The reason I kept two different statements here was so that it was easier to track the performance. So if you're reading my little bullet point here, same workload, about 15, I think it was either 15 or 25, let's say 15 users, bang it against this particular database instance, right, for 10 minutes straight. 7.3 million rows inserted versus only 5.3 million rows, almost 2 million more rows inserted into the same table, same workload, same conditions. Only thing that's different, fast ingest. That's 36% improvement. That's over 1/3 performance improvement, right? And again, I'm not working on huge systems with tons of CPUs or a lot of memory. So again, remember, this is a simple demonstration of the power of fast ingest. Also, note that, again, remember, 2 million more rows inserted. If we look at physical writes, look at the number of physical writes, significantly lower. We still got to write to the segments, right? We got to write to those blocks, right? And notice, by the way, I did use a partition, a named partition called newest, right? Because you can use it with a named partition. That's okay. I should say a range partition. That's permissible, right? Or a hash partition. That's also permissible. In this case, I was partitioning based on the date of when I was writing things into the table. Key point here, lots fewer physical writes, a ton less physical writes, with 2 million more rows inserted. Not too shabby, not too shabby at all. So again, right off the top, 36% performance improvement with a lot fewer physical writes. I wonder if those two things are related. And the answer is, yeah, obviously they are, right? Now remember, there are disadvantages to this. So just don't think it's the perfect solution. Remember the disadvantages and the limitations. Again, isn't life like that? We're always trading space for time, for example, as I used to say. Now, I'm going to go back to one other point, and I do see there's one question in the Q&A. Let's take a look real quickly at what that is. Okay, Boris has commented on the licensing policy that mem-optimized row store, I presume, is must be licensed. I'm not sure exactly. Boris, can you throw that back in there for me? Are you saying that requires additional licensing? Would you double check with me on that? I think that's what you're intending. If you could just fill that in back for me. Appreciate that. But we'll get back to that, I promise. There's another side of the mem-optimized row store. What's the other side? Something called fast lookup. It's essentially the opposite of fast lookup, fast ingest, excuse me. So here's an idea. I can still use the mem-optimized row store for speedier lookups. Here's the idea. I've got a table called T-meter readings, right? I've enabled it for write. I can also enable it for read. In fact, I can enable any other table for read as well. Now, why would I do this? Well, I got a couple of really interesting scenarios. The way to think about this is fast lookup is best for, instead of drinking from a fire hose, again, it's almost the opposite. And what it comes down to is, think about some of these scenarios I've got down here on the bottom. A perfect case for me is streaming, right? Streaming video. Think of whatever streaming video service you have that you subscribe to. Here in the US, we have everything from Amazon Prime through Hulu and Netflix, and you've heard of all these terms, right? What do you think people look at all the time? What can I look at today, right? What appropriate stuff has been added to my queue? What's available today? What is the newest release? Well, think about that. What are people going to be doing? They're going to be hitting against that data almost all the time. Ooh, new movies come out, right? Isn't today, I think, I know here in the US, or maybe even last night, the new Dune movie has been released. What do you think people are going to be looking at? Dune. Probably that's it, right? Or any other of the new releases. So there's a row that's just going to be pummeled all the time. How about something like this? Most recently loaded rows. Think of a sales scenario, right? Show me the most recent store sales. How about large chunks of data that are read all the time, like maybe the description of Dune, whatever it might be. Maybe we've got a nearly fully populated Varchar 2000 column, right? People are going to be constantly going after that data. So instead of caching the block that contains that row in the database buffer cache, what if we cache the row itself? So that gives you an idea why it's more called the mem optimized row. Point, I've got to have a primary key on the table that I'm enabled for fast lookup. So let's take a look at how that works. So if I've got a table set up, this one, the smart meters table for what? Oh, right. Key point. I've got to have a primary key constraint, because basically what happens is we build a hash table in memory that says, here are the rows in these tables for which you can quickly access. And we'll talk about populating and depopulating those rows in a few more minutes here. So just remember, yeah, you got to have a non-deferrable primary key on it. Okay, so I took care of that, and then I wanted to go ahead and try to turn it back on, and there was another little wrinkle I had because I was preparing to test fast lookup. I had 3 different partitions in that particular table, and one of the 3 partitions had no data in it. The newest partition, the partition literally named newest. So I got this error. Like, okay, I got to add some data there first. Now, there, as far as I know, there is no Moz note that says, here are all the limitations for fast lookup. However, there are a list of error messages that I perused, and I'm like, this is where we would draw the Moz note from. So if you run up against some kind of thing that, what is going on here? Look through the error messages from 62.100 through 62.200 to get an idea of what might be causing the error. So just to share that with you, that's the best way to figure out why isn't this working? Go look at the error messages. Sorry, as far as I know, there's no Moz note yet for this. So anyway, let's assume I finally get everything working. How does it work? Well, the first thing I have to do, if I want to take that T meter readings table, right, and populate it. By the way, note, you can populate just one partition. So remember, I said in my T meter readings table, I had a newest partition, and then I had older, and then oldest. Well, maybe all I care about is the most recent partition. So to populate the data into the Morse pool first, I have to use the dbms memoptimize.populate procedure from that package to make it happen. If I want to remove an object, guess what? There's also a drop_object procedure that's part of a dbms memoptimize package that I can invoke. So again, I could have multiple partitions in there and then decide, you know what, it really doesn't make sense. I don't have that much memory in there. And we got that vmem optimized area that we can look at. Oh man, I'm starting to run out of space in here. Let's take one of those partitions out. I would do it with the drop object procedure. And notice I always put exceptions processing in all my PL SQL, even if it's anonymous, because I once followed Tom Kite on a presentation and he said, you should always do that. And I was embarrassed, so I always do it all the time. But I'm a believer in that. It makes sense to do it. So now, how do I know if things were successful? Well, first off, I can look at, I know that query flashed kind of quickly there. Let me go back just one byte there. Let's see, get back up by itself. I can look at everything that has mem optimized right, mem opt R, and see what statistics are available. So by the way, here's what happened from the session I was running. I populated and depopulated the same table several times, 4 times. So in this case, the mem opt R populate tasks accepted was an indication that I had essentially activated a table for fast lookup and then populated it into the database. Notice that there were several entries that were deleted. Yeah, that's when I use the drop underscore object procedure. So again, this is very viewable. Oh, and by the way, if I change that mem opt R string up there in the where name like clause to W, guess what I would get? Everything for mem optimized right for fast ingest. So this is a way to focus only on fast lookup stuff. Now, I can also use that query that I just showed you briefly to take a lower level look. And what's cool about this is note, remember I told you about those worker processes, W000 through W0N? Here's where you can actually see what work is being done. So this was a more extreme case where I had populated and depopulated and repopulated tables and really partitions of tables back and forth into here. You can see an enormous amount of information. I won't insult your intelligence on what all these things mean, but you can see that certain number of rows were added, how many blocks were populated, and so forth. And remember, these are not database blocks necessarily. Really, the way to think about these are blocks in memory, really memory areas of the rows themselves for that table, right? Because that's the way we're getting to the data in this case. Now, a couple of quick examples to really quantify this. Then we've got a little bit more to go and I'm done. And I think, I remember if you're done for the day or shortly done for the day. So I built a little table here called T Smart COS, smart customers, right? Which just had a very smaller, much smaller number of rows. And the primary key is SM, smart meter ID. Now, if I ran the query with a range scan, where I said between key value, right, primary key value between 2688079 and 081, Oracle said, oh, okay, fine, range scan. What? Yeah, because I didn't use an equality predicate. Remember, fast lookup works when I use an equality predicate. When I do, when I say smart ID equals exactly 2688080, then notice the index is still used, but it's an index scan read optimized, and it immediately goes to the table and does the fast lookup operation. So that's how you know. Now, again, cost difference 1. Okay, it's not a big table, folks, right? It's not a huge table here. That's not the point. The point is that I can get extremely quick access to this particular row using fast lookup. If this is a much larger table, the cost, and let's be honest, the actual performance would be much better, right? Because again, I'm not storing the block in which the row exists. I'm storing the rows themselves in the mem optimized row store. And finally, so what? Well, here's what. How would I use all these data? Well, and I'll just give you a couple of quick examples here. I actually do this. I have another presentation on using machine learning and in concert with your Oracle database, right? And this is one of the examples I'm just going to pull out. What I did is I took the data from my smart meters table and I set an arbitrary value of how many, 15%. In other words, how many users of these smart meters happen to have solar panels on their roofs, and they use of their monthly utilization, 15% or more was essentially taken care of by solar power. And so I basically set a binary flag, right? 1, yeah, you're a solar power super user, or 0, you're below 15%. And then I took that and ran that into a k-means algorithm. This is actually real-time data analysis, right? So again, if I'm loading these data on a constant basis, I can tell you right now who are the major users of solar power. And because I'm using machine learning here, I'm also looking for cases like a clustering case to tell me, well, what are the attributes that set these folks apart? Is it that they're mainly city versus rural? Are they mainly manufacturing or homeowners? Do they have more solar panels and more smart meters than others? I can use a clustering algorithm to figure out what are the key indicators, the key features, to use a machine learning terminology, to figure out why they might be solar super users. And here's an example of kind of the inverse of that. I actually took a look, and it may be a little hard to see on your screen, but I took those business descriptions and I isolated out who are the poorest users of solar power. And one of the interesting ones is, again, I use as a background, serendipitously, I used data from the Chicago City public data sources, and I used businesses as my basis. So this one down here, operation of a commercial passenger vessel. Yeah, we actually have water taxis in Chicago. A lot of people don't know we have two rivers that run right through the city. Yeah, I can see that a river boat probably isn't using a lot of solar power. So that's an interesting thing here. Again, what I'm plotting is what's called the centroid, how far away from the center, right? These are the egregious outliers. And I was able to do this in 10 minutes with machine learning and go, there's some interesting outliers here. And again, I could have also looked at who are my best users, right? Anyway, so just a quick example of how you can use, by the way, this is an Apex application I built called IOTA that lets me analyze these things, right? I also have some stuff about using this in geography. And here's an example of it right here. Did you know, now again, this is the older technology, but this is using the Oracle spatial and graph tool set inside Apex, the new Apex map region. If you haven't looked at it, oh my gosh, it's really nice. What I highlighted here are who are the constant solar power super users. And by the way, the blue versus green map points, the green are anything, I think, 25% and higher. So if someone goes, well, show me where your solar super users are, well, guess what? They're everywhere. They're everywhere throughout the city of Chicago, right? So again, there are many ways I can leverage these data for real-time analysis. In fact, I'm going to take this type of analysis forward into 2022. I'm going to be taking a different angle on electrification, talking about, well, where should we put our smart chargers for cars? Because I tell you, in my area of the world, I'm starting to see a lot more Teslas and electric vehicles. And thank goodness, because we're going to electrify everything. That's going to be how we're going to tech our way. One way we're going to tech our way out of climate change. In my opinion, we've got the tech. We just have to go ahead and apply it. In the future, I'm hoping to actually play with more streaming from Oracle streaming services. Oracle does offer that, in case you didn't know that. They ever get this thing fixed with the encrypted table spaces, I want to take this over to an ATP instance and just really bang against that workload as hard as I can to see some better performance improvement. There's a new workload generator that Dominic Giles has been working on. If you guys know Dominic, he wrote Swingbench. He has a new workload generator. I've been kind of collaborating with him on it. I want to try that against this as well for more complex types of IoT streams, including social media. And finally, I've got some extra documentation for you. I'm not going to read this to you, but there's quite a few really good things here. Everything from City of Chicago, if you're really interested in City of Chicago stuff, the architecture of the Moors, and some interesting articles about where things are going with IoT, especially with electricity. And with that, I am done. So let's see, do we have anything else? Boris, I don't know if you answered me back on that yet, but it seems to be the indication that whether or not this feature needs to be licensed separately I think it might be part of, if I remember correctly, the in-memory features. I'm not sure about that, but you know what? Let me find out and I will try to send you an answer. If you want, reach out to me at jim@jimthewhyguy.com and I'll send you a personal answer back. Anybody else? Anybody still listening?
Yes. I was not able to turn on my microphone, my own microphone.
I've had whole weeks like that. And by the way, let me just put up my contact info here. Am I the last one today, Mirella?
Yes, you are the last one today.
Oh, I'm standing between everybody and a refreshment then. I'll just throw my contact in.
But the use case was so packed with different things, different technology, and everything ended up in the database, and it was very interesting to follow the talk. It was completely different than
Well, thank you.
that. Yeah.
Cool.
If anyone has any question to write, if not, they can reach you. You just put your contact.
Absolutely.
I want to add that you wrote an article for Aura World about the same topic.
Yes, I did. Actually, two.
Actually, two, yes, two in two numbers. The one in June, I think, and the last one was released 2 weeks ago. Or,
right. Yeah.
So people can go to auraworld.org and read the article.
Yes.
And I also want to say thank you for the podcast. You know that I'm listening to your podcast.
Oh, I know. Seriously, it has been a lot of fun. And we started out just Liren and I talking to each other. And we're like, this is boring. We got to have some guests. And we've had some really interesting topics. We just interviewed a gentleman, by the way, who is a specialist on, I'm trying to think, he's a specialist with teaching people how to manage other people based on not their personalities, but on their behavior. And that's going to be our opening podcast for 2022.
Okay.
Because it's just so good. We're still editing it and everything. But yeah, we're really focusing on those soft skills for people. And it's a fun listen. Everybody I've talked to said it's like hearing a conversation.
Yes, exactly. So if someone likes to hear a conversation, listen to like a story,
here we go.
Warmly recommend the podcast. You can download it and listen to it offline. It's relaxing and it's interesting in the same time. And well, since I listened to the last one with tricks that you can fall in speaking English when you are a foreigner, I'm thinking twice when I'm using the word interesting.
Yes, it's very interesting. Yes, that is. And again, there's an old saying that British and American speakers of English are two people separated by a common language. I have tons of examples where I think I mentioned in the podcast about traveling with Jeff Smith we were traveling to UKOUG a couple of years ago and we ended up in Liverpool. And they speak something called Scouser, which is like, would you like a bevy with you? And I'm like, what? And the guy just went, would you like a beverage with your breakfast? It's like, yeah, now that you're speaking English, yes, I can understand it. I came to the UK to speak English, for God's sake, but anyway, but yeah, it's funny. Yeah, thank you so much for that shout out. We really enjoy it.
Yeah. So since we have no other question, I think we can close the day. Thank you again, Jim.